Hi students, welcome back in lecture number 3 of our course of CNC machining programming, and let me just recapitulate what we have covered in our previous lecture. So in our previous lecture we have covered about the axis in CNC machines, followed by dimensioning system with respect to absolute and incremental or relative system, and then in the end of our lecture we have covered about fundamentals to manual part programming. Now let me just start our today's lecture, that is lecture number 3. In today's lecture, we will learn about G and M codes used in CNC turning machine along with their functions in detail, and we will also learn how to build up a CNC program in case of CNC lathe machine and what are the different parts that a CNC program consists of and how to build up that. So now let us move ahead and understand what are G codes in CNC turning machine. So G code is a 2-digit number following the address G, determines the meaning of command used in the block. G codes are used to control and modify axis movements for machining. So kindly note that whenever we want to move the axis of a CNC machine, we will always use G codes. And G codes are also termed as preparatory functions, or they are also called as preparatory functions. Now this figure shows the different types of G codes that we will use in our CNC turning programming. And all these G codes are for CNC FANUC controller. Now, as I had explained you in our lecture number 1, that we have different types of controllers which are available in the market. And I had listed some of them to you also, that we have FANUC controller, which is the most popular controller used in our CNC programming. Then we have Siemens controller, we have GSK, Mach3, HMT, etc. Now the difference between all these controllers will be on their codes, but most of the G codes are same in all the controllers, so there is no need to worry about it. Now let me explain you what are the G codes which are written here with their functions. The first code that we have is G00, which means rapid traverse or positioning. Now, when we are moving the cutting tool in such a way that there is no contact between the workpiece and the tool, then we will always use G00 code. Kindly remember this. Next, we have G01, which is for linear interpolation or cutting feed. Now, when we are going to remove the material from the workpiece in a straight line, then we will use G01 code. So remember this, that we are moving the tool in a straight line and removing the material from the workpiece. There we will use G01 code. Next, we have G02, circular interpolation clockwise. Now, suppose we are moving in an arc from point number 1 to point number 2, as you can see here, in this way, clockwise direction, and we are removing the material from the workpiece. So in such cases, we will use our G02 code. G03 is for circular interpolation counterclockwise. Now, let us reverse the position that we are moving now from point number 1 to 2 in this way, like this. This is point number 1, this is point number 2, and we are moving in a counterclockwise direction. So we will use G03 code here. Next, we have G04, which is dual. Here, there will be no motion in the cutting tool. G17 to G19, these are the G codes for plane selection. G17 for XY plane selection, G18 for ZX plane selection, and G19 for YZ plane selection. Then we have G20 for input in inches and G21 for input in mm. When suppose we have a part with us and the dimensions which are mentioned on the part will be in inches, then we will use code G20. And if the dimensions on the part is mentioned in mm or metric, then we will use code G21. Kindly remember this. So G20 and G21. Next, we have G28, which is return to reference point, and this also means home position. And home position is the machine 00 position. So G40 is for tool nose radius compensation cancel, and G41 and 42 for tool nose radius compensation for left and right respectively. G70 for finishing cycle, G71 for multiple turning cycle, and G72 for multiple facing cycle. G73 is for pattern repeating cycle, and G74 is for drilling cycle, G75 is for grooving cycle, and G76 is for multiple threading cycle. Then we have G90 turning cycle, G92 threading cycle, G94 pacing cycle. And we have G96 for constant surface speed control. And if we want to cancel this, then we will use G97 constant surface speed control cancel. Then we have G98, that is feed per minute, or when the feed is in per minute, we will use G98 code. Then we have G99, which is for feed per revolution. Now, there is a relation between feed in per minute or feed in per revolution. So kindly remember this. So 1 per minute, 1 per minute will be equal to 0.001 per revolution. Suppose we have a feed in 80 per minute, let us say. And we want to convert this per minute into per revolution. Now we means that 1 per minute will be equal to 0.001 per revolution. So what we will have to do here, that we will convert this feed in per revolution. That is 80 into 0.001 per revolution. And it will become 80 into 1 divided by 1000. And it will be 0.08 per revolution. It means if we are writing a code G98, then the feed will be in 80 per minute. And if we are writing a code which is G99, then we will have to change this feed 80 per minute into 0.08 per revolution. It means we will use 0.08 in case of G99 code. So I hope it will be clear to you. Now, G codes are categorized as model and non-model codes. So model and non-model are the terms which are used to describe the two classes of codes used in NC programming regarding their ability to remain in the MCU's memory. So what are non-model codes? So non-model codes are used just once and then discarded. On the other hand, model commands remain in the active memory of the MCU until they are replaced by another code. So model codes will remain in the active memory of the MCU until they are not replaced by the another model code. And non-model codes are just used once, and after that they will be discarded from the MCU's memory. Now, as you can see here, that all these G codes are grouped in different categories based on their functions. Now, what does it mean? Let us take an example of G00 and G01 because they are belonging to same category. Now, what does it mean? Now, it means that we cannot invoke G00 and G01 at the same time because it would be analogous to putting our car in reverse and drive at the same time. However, we can have codes from different groups active simultaneously. For example, let us take an example now, G01 and G20, because they are belonging to different categories. So we can use both the codes simultaneously. And this is like having our car in drive and turning on the radio system at the same time. Because they are not related to each other, so there will be no conflict at that time. The advantage of model codes is that we do not have to enter the code in the subsequent blocks if the code has not changed. For example, as we know that this G01 code is used to cut the material in a straight line. Now, if we have a series of straight lines moved to make, we do not have to re-enter G01 in every single block. However, if G01 is replaced by another code in the same group, then the new code will remain in effect until it is changed again. So I hope now these model and non-model codes will be very clear to you. Now let us move ahead and understand what are M codes in CNC turning machine. So in addition to G codes, there are codes which are used for on or off control of the machine functions, such as tool change, spindle rotation, coolant on and coolant off, etc. An M code comprises the M address followed by a number. So M address plus number will become M code. For example, let us say we are taking an example of M03. So M03 code is for spindle rotation in clockwise. So M is here address, M address, as we know, and 03 is the number. So by combining M03, it is becoming an M code, which means spindle rotation in clockwise direction. And M stands for miscellaneous functions also. Just like G codes are termed as preparatory functions, so M stands for, or M codes are also called as miscellaneous functions. So these are different types of M codes that we have, like M00, program stop, M01, optional stop. Now, what is the difference between them? There are many circumstances in which we need to pause the program during execution in order to perform some task. For example, we need to stop the program to clean chips out of the cutting zone or off a drill. Now, there are two codes which we will use in order to stop the program, that is M00 and M01. So M00 is an unconditional program stop. When the control reads the M00 code, it will stop all axis motion until the operator presses the cycle start button again. And M01 code is called an optional stop. The M01 functions identically to M00 except that it functions only when the operator has enabled the optional stop button on the control. Next, we have M02 program end, and there is one more code which is here, M30 for program stop and rewind. Now, what is the difference between both of them? Because both are used to end the program. Let me explain this to you. Out of M02 and M30, M30 is the code which is mostly used in order to stop the program. Because M30 will stop the machine wherever it is currently positioned and reset the memory to the top of the program. But on the other hand, M02 code, it does not reset the memory. So that's why M30 is mostly used. Next, we have M03, spindle rotation in clockwise direction, and M04 is spindle rotation in the counterclockwise direction. Then we have M05 for spindle stop. Then we have M06 for tool change. M08 is for coolant on, and there is one more code which is used to on the coolant, which is known as M07. So what is the difference between M07 and M08? Now, as we know that coolants are often used in machining operations to extend the tool life, flush chips away, and improve the surface finish. Most machine tools are equipped with a flood coolant system that sprays a continuous stream of liquid coolant into the cutting zone through a flexible hoses. And other machines may also use a mist coolant system that can spray a mist of compressed air and coolant onto the cutting tool. M08 code is the general code for turning on the coolant system. However, M07 may be used to differentiate between flood and mist system on machine tools equipped with both systems. After that, M09 is for coolant off, and M10 is for chuck open, and M11 for chuck close. M30 we have explained already. After that, we have M62 to M77 codes, which are rarely used. Then we have M98 for subprogram call, and M99 is for subprogram exit. Now, modal and non-modal codes in M codes. Although M codes are not traditionally thought of as modal or non-modal, a few M codes can be thought of as modal, such as those that are used to control the spindle speed or coolant on and off. They simply throw a switch that will remain on until the another code is used to turn it off. However, most M code functions are non-modal, so kindly remember this. Next, we have program builder for CNC Lathe. Now, CNC program can be divided into three parts. The first part is startup of program. Then second, we have profile program and end of program. Now, let me explain you the startup program. So here, our CNC program will start with the letter O, which will be followed by 4 digits like 1000. So it may be anything else like 1234. So this first line stands for program name. Then we have G21 and G99. These are called as initial settings. So as we know that G21 is for input in mm and G99 is for feed in mm per revolution. So these are our initial settings. G28 U0W0 is for home position. For machine 00. And M06 is for tool change. Now in tool change, this 01 is a tool number and next 01 is a tool offset. Let me write here. This 01 is stands for tool number. Next 01 stands for tool offset. Let me explain you this with the help of this figure. Now, as we know, this is the inside view of a CNC machine. This is our spindle. This is our chuck. And this is the turret. This is called as our turret or tool magazine. And we know this is our tailstock. So there are different types of tools that are available here on the tool turret. And the numbering, respective numberings are also given for the each tool. Let us say there are 8 number of tools here. So this is 1 number tool. This is second number of tool, third, fourth, fifth, this is sixth, seventh, and eighth. So the respective numbering is also given, like 7 number tool is here, 8 number tool is here, just like that. So this 01 stands for tool number. So whatever tool that we are going to use in order to perform the operations, that we will mention here. And next 01 is for tool offset. Immediately after the tool number, we need to specify the tool length offset. And the method varies, but it is common to use the G43 code followed by an H word to indicate the number of the offset. To avoid confusion, it is common practice to use the same number for the tool and its length offset. Suppose we can write G43 here and H01. So 01 is the tool length offset, which we are using here as tool length offset. So we are using a code that is M06, T01 and 01. So I hope it will be now clear to you. In this figure, you can see that the bed of our CNC machine is inclined. And in order to specify the x-axis now here, how we can specify? We know that we will keep our job here. And this is the longitudinal axis. Since the tool is approaching from here, so this will become our x-axis, which will be our positive x. And this will be our now z-axis, which is a positive z-axis. Since the tool is approaching from the upside, it will become your positive x. After that, we have profile program, which is based on given part drawing. And the last part is end of the program, which consists of G28 U0W0, which stands for returning the tool to its home position. So this stands for home position. Then M05 is the spindle stop. And M30 is for program stop and rewind. So this is how we can build up a CNC program in case of CNC lathe machine. So this is all for our lecture number 3. And now from our next lecture, we will start our CNC turning programming. So thank you so much for being with me in this lecture. Thank you so much.